Now let's move on to a different technique. It's called logarithmic differentiations. And in this logarithmic differentiation technique, usually get applied to find the derivative of some function that looks like a power function, but it's not a power function. Sometimes look like the exponential function, but it's not the exponential function either. So it's a very tricky situation. The function is complicated, is neither a power function nor exponential functions. When we run to those functions, we can apply logarithmic differentiation. You will see in a minute the type of functions that we have to do with. But there are certain procedure for logarithmic differentiation technique that we can follow that help make the problem a little bit easier to do it. Okay, so here are the steps of logarithmic differentiations. The first step is to consider the function itself. Nice, just right. Consider y equal to f of x. Right. And for the second step, you take the natural log on both sides of these equations. So you get take ln on both sides of y equal to f of x. Right. So that is, you have ln of y equal to ln of f of x. Then the third step is to apply the properties of logarithms to rewrite usually the right-hand side of the equations. Use properties of logarithms to rewrite the resulting equations. And you will see that most of the time, we just use the power property of logarithms, but that's for later. In the first step, you differentiate both sides of the equations with respect to x. WRT in this case means with respect to x. That is, you have d dx of ln of y equal to d dx of ln of f of x. And for the left-hand side, you always going to have 1 over y times dy dx, right? 1 over y because the derivative of ln of y is 1 over y. And you still have to multiply with the derivative of the inside functions, in this case, y. So equal to d dx of ln of f of x. And from here, you solve for dy dx or y prime, right, to find the derivative of the functions, which is dy dx equal to y times d dx of ln of f of x. Right. And for the final step, because in the result, you still have a y, so you want to substitute y back into the solutions to get the final result. So that is substitute y equal to f of x back to obtain the final result. Before we jump into some examples, let me write down the properties of logarithms one more time. All of these properties you have seen before in pre-calculus, but I just want to remind you the following 7 properties of logarithms. So that might be useful for you when you deal with logarithmic differentiation technique. All right, so for properties of logarithms, the first one is the log of base a of 1 is always equal to 0. You learn in pre-calculus that you can ask the questions like, what power should I raise a to get 1? So the power we need to consider is 0. So a to the 0 is equal to 1. Or in this case, log of any base of 1 is always equal to 0. So the next property is log of base a of a is equal to 1. So you can ask the questions, what power should I raise a to get a? So the answer is 1. Number 3 and number 4 properties are called the cancellations property. So that means you have log of base a of a to the x is equal to x. In a way, even though, as I mentioned before, it's not mathematically correct to say this, but it's convenient for us to understand. In this case, log functions cancel out with exponential functions, so you can obtain the power x in this case. Right. On the other hand, if you have a to the power log of base a of x, so that means now you consider exponential functions and logarithmic functions, and they are cancel out in the way, and you're left with x. And this two property, as I mentioned, is called the cancellation property. Well, for number 5, you have product property. So for this product property, if I consider log of base a of x times y, this should give me log of base a of x plus log of base a of y. The next property is the quotient property. When I consider log of base a of x over y, I have a log of base a of x minus log of base a of y. Right. And for the last property, which is the most useful for logarithmic differentiation technique, is the power property. For this power property, if I consider log of base a of x to the power n, this is equivalent to n times log of base a of x. So that's it for the procedure and the properties of logarithms. Now let me move on to some example. Right. I will follow the procedure and I will remind you the power property over and over again. And hopefully at the end of this lecture, you can be able to understand how to correctly apply the logarithmic differentiation technique. So example 7. Use logarithmic differentiation to find the derivative of y equal to x to the x. Right. So as you remember earlier, I mentioned that we will deal with a function that is not a power function, nor is exponential functions. So this is the type of function that we have to deal with. Right. So this function x to the x is not a power function because the power is not a constant. And it's not an exponential function because the base is not a constant. We cannot categorize this particular functions. So therefore, we have to use some other technique in order to find the derivative of the function. Right. So in the technique we want to consider is logarithmic differentiations. Now let's follow the procedure. So the first step is just write down the function again, y equal to x to the x. The second step is to take the natural log on both sides of the equations. So I have ln of y equal to ln of x to the power x. And the next step is to use the property of logarithms to rewrite the right-hand side of the equations. So this gives me x times ln of x, and that is the power property of logarithms. The next step is to take the derivative on both sides of the equations with respect to x. I get d dx of ln of y equal to d dx of x times ln of x. So the left-hand side is always going to be the same, right? Is the derivative of ln of y, and the derivative of ln of y is 1 over y times dy dx. And the derivative of the right-hand side, as you can see, this is a product. The derivative of the product tells you that you need to apply product rule. So that is the derivative of x times ln of x plus x times the derivative of ln of x. Okay, now look at the right-hand side. The derivative of x is equal to 1, and the derivative of ln of x is 1 over x. So I get 1 over y times dy dx equal to 1 times ln of x plus x times 1 over x. Right. Now we're done with all the derivatives. The job now is to solve for dy dx. Right, to solve for dy dx, I'm going to multiply both sides for y to obtain dy dx equal to y times ln of x plus 1, because x simplify with 1 over x to get 1. At this point, the answer contains y. So we don't like that. We want everything in terms of x. So therefore, you go back and take a look at the original function y equal to x to the x. Substitute that into the result you just got to obtain the final solutions. So that is dy dx equal to x to the x times ln of x plus 1. Next example. So in this problem, we would like to differentiate y equal to x to the power square root of x. It's neither a power function nor the exponential function. Okay. So what we can do again, we just start by writing y equal to x to the square root of x. And next step is to take the natural log on both sides of the equations. You get ln of y equal to ln of x times square root of x, and use the power property of logarithms to rewrite the right-hand side of the equations. This gives me square root of x times ln of x. So let me note that I use the power property. The next step is to differentiate both sides of the equations with respect to x. This gives me d dx of ln of y equal to d dx of square root of x times ln of x. So the left-hand side is always going to be the same. Right? So derivative of ln of y with respect to x and give me 1 over y times dy dx. For the right-hand side, you have the derivative of product. It tells you that you need to apply product rule. So that is derivative of square root of x times ln of x plus square root of x times the derivative of ln of x. The left-hand side remains the same. For the right-hand side, derivative of square root of x, again, you need to change square root of x into power functions, x to the power 1/2, and then take the derivative of x to the power 1/2. That is 1/2 times x to the 1/2 minus 1 times ln of x plus square root of x times the derivative of ln of x. And the derivative of ln of x is 1 over x. Right. So you can solve for dy dx at this step. This gives you y times 1/2 times x to the negative 1/2 times ln of x plus square root of x over x. Right. Again, the result we just got contains y. Right? We don't like that. We want to obtain the solutions in terms of x only. So that means you go back to the original functions, y equal to x to the square root of x, and substitute that into the result to obtain the final solutions. That is dy dx equal to x to the square root of x times 1/2 times x to the negative 1/2 times ln of x plus square root of x over x. Next example, here I have a function y equal to sine of x to the power x. At this point, hopefully you have some idea of how to approach this type of problem, right? Again, look at the functions and think about power function and exponential function as yourself. Is this really a power function? Is this really an exponential function, right? So look at this function. Side of x, the base is not a constant, so that is not an exponential function. In the power is x, the power is not a constant, so is neither exponential function nor a power function. So you need to apply logarithmic differentiations to tackle this problem to find the derivative of the function. Right. So first write y equal to sine of x to the power x, and then take ln on both sides of the equations. And use the power property of logarithms to rewrite the right-hand side, which gives you x times ln of sine of x. Right. And then remember what we want to do is to differentiate the functions. So that means differentiate both sides of the equations with respect to x. That is d dx of ln of y equal to d dx of x times ln of sine of x. Right. Again, the left-hand side remains the same for most of the functions. You have 1 over y times dy dx. And on the right-hand side, you have the derivative of a product. So you have the derivative of x is equal to 1 times ln of sine of x plus x times the derivative of ln of sine of x. Right. So you still have 1 over y times dy dx on the left-hand side. The right-hand side give you ln of sine of x plus x. Now take a look at the derivative of ln of sine of x. Right. The derivative of this is 1 over sine of x times the derivative of the inside function. Right. And derivative of inside function is sine of x prime, which is cosine of x. So this gives me 1 over y times dy dx equal to ln of sine of x plus x times 1 over sine of x times cosine of x. Now at this step, you can solve for dy dx. So that is dy dx equal to y times ln of sine of x plus x times cosine of x over sine of x. Now you substitute y equal to sine of x to the x back into the result to obtain the final solutions. That is dy dx equal to sine of x to the power x times ln of sine of x plus x times cosine of x divided by sine of x. Now for the last example, let's go through the process one more time. Look at the function and consider if this is a power function or an exponential function. Okay, so the base in this case is x, so it's not a constant, so it's not an exponential function. The power is cosine of x, so it's not a constant. That means the function is not a power function. So therefore, in order to find the derivative, you need to apply logarithmic differentiations. So first, write y equal to x to the cosine of x. And then take ln on both sides of the equations. You have ln of x to the cosine of x. And use the power property of logarithm to rewrite the right-hand side. This gives me cosine of x times ln of x. Because the requirement is to find the derivative of the function, that means you differentiate both sides of the equations with respect to x. That gives ddx of ln of y equal to ddx of cosine of x times ln of x. Right. On the left-hand side, the derivative of ln of y is 1 over y times dy dx is equal to the derivative of a product. You apply product rule, right? So cosine of x prime times ln of x plus cosine of x times ln of x prime. Right. So on the right-hand side, the derivative of cosine of x is a negative sine of x. Times ln of x plus cosine of x times the derivative of ln of x, which is 1 over x. Now at this point, you can solve for dy dx. That is dy dx equal to y times negative sine of x times ln of x plus cosine of x times 1 over x. And to obtain the final result, the final solution, you substitute y equal to x to the cosine of x, which is the original functions. That is dy dx equal to x to the cosine of x times negative sine of x times ln of x plus cosine of x over x. So this is it for lecture 15. In lecture 15, we'll look at differentiations of exponential functions and logarithmic functions. And we learn a new technique called the logarithmic differentiations. I hope this helped. Please let me know if you have any questions.